Hello everyone and welcome to this video. In this video, we're going to talk about the rest of Unit 10 lessons, 10.2 graphs of quadratic functions. Now, in graphs of quadratic functions, it's the same question that we answered in the first lesson, 10.1. This question is this question here. It's the same, just fill the gaps, find the points, the coordinates of the points, and then draw or sketch the graph, okay? Now, here, let's do the other questions that have more ideas. So same idea here about sketching, quadratic function sketching, same idea. And then here, yes, it's the same idea. So sketching a quadratic function have the same idea. So let's move on. Here we have turning points. Of course, when you sketch a graph, it will look something like this, maybe like this, or the opposite. Now, if it's looking like this, it means it has a turning point of a graph. This point is the point where the direction of the graph changes. For example, from here, it was going up until this point, and then it's going down. The turning point here, it's called a maximum turning point. A maximum turning point because it goes, the maximum point that it goes up, it stops here, and then it goes back down. And here it's called a minimum turning point because the graph goes down to the lowest point and then goes back up again. So it's called a minimum turning point or a maximum turning point. The plural of maximum here is maxima, and here it's called minima. So maxima and minima points. Now let's move on the rest of the questions. I think this covers the whole thing here. So as we said, the quadratic graphs are explained in the first part of Unit 10. So you can check how to sketch a graph or plot a graph using the formula and the table that you have. Now, in 10.3, we have simultaneous equations. Simultaneous equations. Solving simultaneous equations here. Let's take a look at the questions here. This one is about simultaneous equations and how to solve them. First, let's take a look at this. A second. Here. Solve these simultaneous equations. Here, we have some simultaneous equations that can be solved using the substitution method. So the meaning of substitution method, it means you have to take the value and substitute it instead of the variable. So let's cover this here and do the work so we can understand the idea. Let's cover this, and this here and here. Okay, so first we take a look at the equations that we have here. Let's cover this one too. 3x plus y equals 15. 3x plus y equals 15. And then y equals 2x. In these simultaneous equations, we're going to take the value of y, which is this one, and substitute it instead of the y in the first equation. So because the y equals 2x, I'm going to remove this y and put 2x instead of it. So I'm going to write the equation again, rewrite it. So 3x, let's make it bigger so we can see it. So 3x plus y, I put 2x instead of it. So it's going to be like this, plus, and I put it inside the bracket, so 2x. And I'll tell you why we put these inside brackets, and then equals 15. Basically, I put the values inside a bracket because if this one is negative, it will change the sign of these ones inside. If it's positive, it doesn't change them. So I end up with 3x plus 2x equals 15, like this. But if this one is negative, it means it will change the sign of the values here. Now let's continue. So 3x plus 2x will equal what? Very good. 5x. And then equal 15. Now I need to find the value of x. How do I do this? I make the x the subject. Here it's multiplied by 5. It means I can take the 5 to the other side by dividing. So I'm going to divide this side by 5 and remove it from here. So x will equal 15 over 5. and then x will equal 3. Very good. So here I found the value of x, and this was the first part of solving simultaneous equations. Now I want to find the value of y using the value of x. It means I'm going to take the value of x, which is 3, substitute it instead of this x to find the value of y. So I'm going to write the equation again. Y equals 2x, and then y equals 2. I want to remove the x and put brackets and put the 3 inside the bracket like this. And then y will equal 2 multiplied by 3, which will equal 6. And this is the value of y from these simultaneous equations. And by that, I found the value of x and the value of y. And this is how you solve simultaneous equations using the substitution method. Now, let's move on to the next questions. Here, same idea with all of these questions, simultaneous equations using the substitution method. Here we have word problems that lead to simultaneous equations. It means when you read the word problem, you'll find the simultaneous equation and then you'll solve it. Now, we don't have to do the simultaneous equations or solve them. I'm just going to help you how to find the equations over here, okay? So let's start with the first one here. This one. I'm going to write the equation for each one of them and then of the equations, and then you're going to use them to solve the simultaneous equations, okay? Okay, so for the first one, let me cover this. You don't have to cover, so you can read it directly, okay? So 5 oranges and 4 watermelons, or one watermelon, I'm sorry, cost $6.30. The cost of one watermelon is 5 times the cost of one orange. Now, you can use them as O and W. If you don't want to mix them, you can use them as O and W, like this. O for orange and W for watermelon. And when you write the equation, you'll write it like this. Let's make this smaller. So 4 oranges, which is 4O. If you don't want to mix them, you can use them as X and Y. So you don't have an O as maybe you'll think that it's 0 or 40. You can make it an X and Y, okay? So let's make this X and Y. Maybe it's easier for you. So this one is X, this one is Y. Now to write the equation, so 4x and means plus. One watermelon means Y. You don't have to write the one. Together they cost $6.30, so 6.30, like this. This is the first equation. Second equation, the cost of one watermelon, which is a Y, so you say Y equals 5 times the cost of one orange. 5 times the cost of one orange, it means equals 5x. 5x. And this is how you write these simultaneous equations. You can solve them using the same method that we did in question 3. But here I'm just explaining how to write the equations again, okay? This is the equation for question 4. Now let's take a look at question 5. A sports venue holds 720 people with 15 standing rows and 10 seated rows. So let's call this X, the standing, let's call it X, and the seated, let's call it. So all of them are 720. So we write the equation like this: 15x, as they said here, 15 standing, plus 10w, which is 10 seated, 10 seated, which is 10w. Together will equal what? Will equal 720. So together they will equal 720. Now, each standing row, which is the x, holds twice the number of people as a seated row. This means the x will equal each standing row, the x, holds twice the number of the people as a seated row. So equals to y. So x here equals to y. Now, again, the sport venue holds 720, so all of them are 720. 15 standing, so 15x, 10 seated, so 10y. And then we put them as an equation like this, and then each standing, which is x, holds twice the number of people as a seated row. Holds twice the number of people as a seated row. This one needs to be, yes, this one needs to be understood. Each one standing row, holds twice the number of people as a seated row. So a seated row should be two, and the standing should be one. Okay, that's the whole idea. So as we said, that each standing will equal two seated rows. Okay. Now this is the simultaneous equations that we're going to use, and then you're going to solve them the same way that we did in question 3. Same idea here in question 6. It costs one adult and three children $17.50 to go to the cinema. A child ticket costs half the price of an adult ticket. So let's write the equation here. First, let's call the adult X and the child Y. So one adult, which is X, plus three children, which is 3Y, equals what? Equals, let's see, 17.50. And then that's the first one. A child ticket, which is Y, equals a child ticket costs half the price of an adult. So Y equals 0.5x, because the adult is twice the child, or the child is half price of the adult. Okay, so these are the simultaneous equations that we're going to use to solve the question. Okay, same idea. You can use the same method that we did in question 3 to solve them. I don't have to do them again because they have the same steps. Okay, now let's move on to the next question. We have other simultaneous equations. We have this one, question 7. Let's take a look at it. At the school play, let me cover this so I can use the space. Yes. At the school play, uh, students sold programs for $4.50 and ice creams for $1.50. They sold twice as many ice creams as programs. Altogether, they made $322.50. How many programs and how many ice creams did the students sell? Okay, so basically, let's call the programs X and the ice creams Y. Okay. So the students sold programs for $4.50. So X will equal $4.50 or 450. And the Y will equal $1.50. They sold, this is one of we have the values here. Okay. They sold twice as many ice creams as programs. So the ice creams, they sold twice as many ice creams. So the ice creams are double the programs. So it means that 2y will equal x, right? 2y will equal x. Altogether, they made 322 point or dollar 50, $322.50. And altogether, they made 322.50. So they sold twice as many ice creams as programs, and we already have the values. Now we need to know how many programs and how many ice creams did the students sell. Now, the last equation, which is altogether they made $322.50. I'm gonna write it like this, okay? So first, let's put it here. So altogether, it means the programs and the ice creams together, each one costs this one. So I'm gonna write it like this. So how many programs? I don't know, but I know that each one costs 450 multiplied by programs, which is X, plus the Y, which is the ice creams. Each ice cream costs $1.50, so $1.50 multiplied by Y together, it will equal $322.50. Okay, so this is the first equation. That's the first equation. I know that each one of them costs this one, but I want to know what's the total of programs and the total of ice creams. And then the second equation is this one. It's 2y will equal x, which they sold twice as many ice creams as programs. So basically, I'm going to substitute this, the 2y, instead of this x, and then do the solving steps that I did in question 3 and follow the same ideas of substitution method. That's it for this question. I hope you understood the idea. Follow the same steps and you'll get the ideas, okay? Now let's move on. That's the idea of solving simultaneous equations using substitution method. Now here we have simultaneous equations using the elimination method. The elimination method. Now let me show you one of the questions we'll solve together. Let's do F. Let's do something that has different numbers. Yes, this E. Let's cover this. Here we have two simultaneous equations that can be solved using the elimination method. Now, in the elimination method, it means you have to eliminate one of the variables. How do you eliminate variables? You have to look at the variables. If they have the same, it's very important. They must have the same coefficient and different signs. If they have the same coefficient and different signs, it means you can eliminate them. If they have different coefficients, you can't eliminate them. They must have the same coefficient and different signs. Now, let's say one, like the two equations don't have the same coefficients, both of the variables don't have the same coefficients. It means you have to pick one of the variables and make it have the same coefficient and different size. But here they already have the same coefficients and different signs. It means I can cover on them like this, cover them, and eliminate them like this. So both of them are eliminated by addition because 2 minus 2 is going to be 0. Now I'm going to add the rest of the equation. So 6x plus x equals 7x. 6x plus x is 7x. And then 51 equals 51 plus 5 equals 56. Now I need to make x the subject or to find the value of x. So because this is multiplied, I'm going to take it to the other side by dividing. So x will equal 56, I'm sorry, divide 7. 56 divide 7. So 56 divide 7, x will equal, yes, sorry, 56 divide 7 is the value of x, which is 8. So the first thing or the first step that I need to do was finding the value of x. And here I found the value of x. Now, I'm going to take the value of x and substitute it in one of the equations to find the value of y. So I'm going to take the 8 to any equation I want. If I want the first one, I can work with it. If I want the second one, same idea, I can work with it. Let's say we want the first one here. It will give me the same answer. So I'm going to write the equation again. So 6x plus 2y equals 51. Now, the value of x was 8. So I'm going to remove the x and put brackets and put 8 instead of it. So bracket 8 and then plus 2y and then equal 51. So the main idea, I remove the variable, I put bracket, and I put the value of x instead of the bracket or instead of the x. Now 6 times 8, 6 times 8 multiplied inside brackets, it's 48. So this one is 48. And then plus 2y equal 51. Now I need to make y the subject. This means I have to take the 46 to the other side because it was added. It means I'm going to subtract it. So here we have 2y equals 51 minus 46. So 51 minus 46 is going to be 5. 51 minus 46 is going to be 5. So 2y will equal 5. Now I need to find the value of y. It means I have to make it the subject. This one is multiplied. It means I have to take it by dividing. By dividing. So I'm going to take it by dividing over here and remove it from here. So the y be what? Y equal 5 divide 5 divide 2. And 5 divide 2 will equal, very good, 2.5. So the y will equal 2.5. And this is how you find the values of x and y. And this is how you answer a question like this. So this is called the elimination method. The rules of elimination method, you need to have a variable with the same coefficient and different signs. If you already have it, just eliminate and add the others and solve for x and y. If you don't have it, it means you have to change the coefficients by multiplying and the signs by multiplying by a negative one. Now, let's move on to the next question. That's the idea of simultaneous equations. Okay. Same idea with all of them here. And then here, same idea, same coefficient. You have to make them different signs. That's it. By multiplying by negative one. I'll show you the steps here. Now, some questions you have to write your own equation. Let's do this, and then I'll show you the problems that needs you to write the answer or write the equations and then answer. Here, see, in this or these simultaneous equations here, I'm not gonna solve the or finish the equation. I'm just gonna tell you how to change it to make it have the same coefficient and different size. So basically, first you look at the equations, you find out that these two, or this variable here, the x, they have the same coefficient, but the problem is that they have the same sign. This means you have to change one of the signs. And changing one of the signs will need you to multiply by negative one. So basically, I choose one of the equations. I choose the smaller one here, and I multiply it by negative one. So negative one, multiply the whole equation, okay? And when you multiply the whole equation. So I'll put this here, so on this. So negative one, you multiply it by the whole equation, like this. Basically, the negative one just changes the sign for all of them. So let's first write the equation here. So 3x plus 9y, sorry, equals 66. And then the second equation after multiplying, we just change the sign. So negative 3x and then negative 3y and then equals negative 30. Okay. So basically, only the signs change because of this multiplying or multiplication. Now I look at the variables again. I find out that they have the same coefficient, different signs. It means I can eliminate them. And I eliminate them by addition because 3 minus 3 will equal 0. This one is eliminated. Now I add the others. 9 minus 3y will equal 6y. 66 minus 30 will equal 24. 26, I'm sorry. Uh, 36, sorry. Yes. So 66 minus 30 will equal 36, yes. Now, I find the value of y by making y the subject. The 6 is multiplied. It means I have to take it by division. So the 6 will be here. And because I took it to the other side, I can remove it from here. So the y will equal 36 divided 6 will equal 6. And this is how you find the y. Now, after finding the value of y, I'm going to take it and substitute it in one of the equations to find the value of x. I can use this one or this one. Same idea. Let's use the second one. So here I have 3x plus 3y equals 30. Now, I already know the y. So 3x plus 3. When I remove the y, I put bracket and I put the value inside the bracket and then equals 30. So 3x plus 18, which is this times this, equals 30. Now I need to make the y the subject. I'll take the 18 to the other side because it's addition. I'm going to make it subtraction. So 3x will equal 30 minus 18. 3x will equal 12. So 30 minus 18 will equal 12. Now, I want to make x the subject. So the 3 is multiplied. I'm going to take it by dividing over here. So the x will equal 12 divide 3. Let's write it here. Divide 3. And 12 divide 3 will equal 4. So the value of x is 4. And this is how you answer a question like this. In simultaneous equations, make sure that you have two variables that have the same coefficient and different signs, so you can start the elimination method. That's it for this question. Let's move on to the next question. Let's move on. So next question here, as we understand, these questions are direct. The other ones, they need to, you need to write your own equations to find the simultaneous equations, okay? So let's take one of the questions here. Let's start with 13. Let's write the equation here. At a water park, two adults and two children pay $21 for entry. A different group of two adults and five children pay $30. Work out the cost of one adult and the cost of one child. So basically, let's make this the x and this the y. So we have the x and the y. Now, to write the equation, two adults means 2x. So 2x, let's make it smaller. Smaller equations size so we can see them. So 2x and means plus. 2y or two children means 2y equals 21. This is the first equation. Now, a different group of two adults, so 2x and means plus. Five children, 5y equals 30. Now we have two simultaneous equations. We have to use the same method that we used before. Basically, we're looking for what? A variable that has the same coefficient and different signs. This one has the same coefficient, but the signs are the same. So you have to multiply one of them by -1 to make it different and follow the same steps of simultaneous equations. And this is how you answer a question like this. Thank you very much for watching. See you next time.